I'm Dr. Jennifer Moses, and today we're going to be using PSPP, the free open source statistical analysis software package, to create z-scores. Now, as a reminder for those who maybe forget what z-scores are, they're a data transformation, where we take raw scores that have been uncooked, and we transform them into a standardized metric. Essentially, let's say we're measuring height in inches and weight in pounds. We would then convert them into standardized z-scores, which would then tell us how many standard deviations a person is above or below the average. So a person may have a height of 78 inches, but their z-score might be positive 2, which would indicate they are 2 standard deviations above the average. 2 tells me that they are 2 standard deviations away, and the positive sign would then tell me that they are above the average. So let's then dive right in and refresh our memory of what we're looking at when we look at the data view in PSPP. So this is what is called the data view. Here there are these 2 tabs at the bottom. There's variable view and data view. Each column is a separate variable, which is a way that people can be different. And then each row is an individual person. So person 1 has a height of 78 inches and a weight of 156 pounds. Person 3 has a height of 80 inches and a height of 160 pounds. And as another reminder, at the top of your screen in PSPP, you see various analysis options. We are going to use the Analyze Descriptives command today. So the first step in converting our raw scores into z-scores is to click Analyze at the top of your screen. And then you're going to choose Descriptive Statistics from the drop-down menu. And then you're going to choose Descriptives again. So Descriptive Statistics, and then a new drop-down menu where you will choose Descriptives. And you'll see a pop-up window that looks like this. Over here on the left is where your variables will be, a whole list of them. And then you're going to use this little arrow here to select your variable and move it to the right. And then you're going to choose some statistics like the mean and the standard deviation, because then you'll actually see what the mean and standard deviation are for your variables of interest. And then you're going to click this little box here that says Save z-scores of selected variables as new variables. And what PSPP will do for you it will actually create brand new columns with the standardized height and the standardized weight. So I do that, and then you click OK. Make sure this is checked where the red arrow is pointing. And then I cruise down, and this is what the output file looks like. And to refresh your memory, when you work with PSPP, you'll have a data file and then an output file where the results of all of your analysis get saved. So here I use the descriptive command to get the height and weight. I asked for the mean and standard deviation, and then I also asked it to create z-scores. So height is still there, but I have a new variable called z-height. Weight is still there, but I have a new variable called z-weight. And then I have, that tells me the mean and the standard deviation of height, and then the mean and the standard deviation of weight. Height has an average of 69.67 with a standard deviation of 4.06. Weight has an average of 145.1 with a standard deviation of 16. To refresh your memory, the mean is the one value that summarizes everybody's scores. So 69.67 is summarizing everybody's actual heights, give or take 4 inches, a standard amount of deviation from that mean of 4.06. So if I scroll down a little further, I can then see back in data view of my data file that not only do I still have the height and weight variables, I now have 2 brand new columns, z-height and z-weight, where yes, person 3 had a height of 80 inches, but in z-scores, their new transformed standardized value is 2.55. They are 2.5, just over 2.5 standard deviations above average. And if we look back here at what the standard deviation was, it was right around 4. The mean was just under 70. This person is a full 10 inches above average, which is about 2.5 standard deviations. 2 standard deviations would be 2, and then a little bit more than that, another half of a standard deviation. So for a total of 80. So this person we know is above average because their z-score is positive, and we know that they are 2.5 standard deviations, 2.5 fours, if you will, above the average. Or let's look at person 1. They were 8 inches above average, about 8 inches above average, see, about 8 inches above 69.67, and they're just over 2 standard deviations above average because the standard deviation was 4, and they were not 4 inches above average, but 8 inches above average. Because again, that's all the z-score tells you. It tells me how many of these things, standard deviations, this person was above or below average. And then the same thing for weight. So now we can then save our new file. We wouldn't want to lose our standardized variables. So we're going to go to File, Save As, and then we'll have a brand new data file that will not only have our raw scores, but our z-scores as well. And before I sign off, I do want to actually show you how I can play around in the real PSPP program. So let's go do that now with a brand new data set. So first, again, you're going to save your new file, right? PSPP data file, something like that. You got to save it because it's got 2 new variables, right? So save it as something new like data set standardized, and then click save. And now we're going to go over to the real PSPP and take a look at it. So here we are inside PSPP in a different data set called the student survey data set. And I'm just going to show you how first I'm going to transform one of my quantitative variables. And as a reminder, quantitative means the way that people differ is by amount. So height, weight, extroversion from more to less, how many pets you have. If we click inside the data view of this file, we can see GPA is quantitative, number of pets you have are quantitative, how many caffeinated beverages someone has had in a day is quantitative. So I'm going to choose one of these quantitative variables to standardize. So I'm going to go to Analyze, Descriptive, and then choose Descriptives. And I'm going to see a pop-up menu that looks like this. And I'm just going to choose the mean and standard deviation. I don't need any of these other statistics. And I'm just going to, let's just do weight or height because that's what we were doing before. So where is my height variable? What is your height in inches? How tall are you in inches? So I'm just going to use this to move it over there. And why don't we also choose how many caffeinated beverages someone has had, or how about sleep? Yeah, let's choose how much sleep someone has had. And so again, I'm going to make sure to toggle this, save z-scores of selected variables as new variables, and then I'm going to click OK. So now that I'm back in the data file, I can then cruise over, and what PSPP is going to do is it's going to save those standardized variables all the way at the end. So here they are. See, I have z height and z sleep. And this is my new standardized set of variables for both height and weight. You can see this person is very below average. Whoa, this person is 4 standard deviations below average. This person is also below average on sleep. My. This person is above average on height and above average on sleep. Right, so we're just going to look, this tells us how many standard deviations someone is above or below average. I'm also going to click Analyze, and now I'm going to use the Descriptive Statistics command again to get the, and I'm not going to save the z-scores again, but now I'm going to get the height and sleep again. And I'm also going to ask for the mean and standard deviation of the new standardized variables, because then in one little output, I'll get the means and standard deviations of all 4 of these variables. The raw scores for height and the z-scores for height, the raw scores for sleep, and then the z-scores for sleep. And then I just click OK. And we're going to go to the output file. And so here we have that original output file. Right, this is when I had just the raw scores. And so this is when this was the very first thing that I did, right? It created my z variables, and then it also gave me the mean and standard deviation of both height and sleep. And then if I look down the output file, Here we can see this is just what I asked for just now. Here is height in raw inches. Here is how many hours of sleep people get in a night on average. And then here are the two standardized variables. And as we can see, the average raw height in this particular data set of 57 people, Big Mama N always means all the people, of these 57 people, we can see that the raw average was 63.39 with a standard deviation of 14. So yes, the average height was 63.39 inches, but with a significant amount of standard deviation. The standard deviation was 14 inches. So we have a lot of spread around that average. There was less variability with sleep. The average number of hours people got of sleep a night was 6.9 with a standard deviation of 1.67 hours. But then when you look at the standardized variables, the new average is 0 and the new standard deviation is 1 because that's the nature of taking the z-score transformation. And as a reminder, what the z-score transformation does is it subtracts the average from everyone's score. So now whatever your raw number was, you're going to subtract the average from it. And then you're going to then divide by the standard deviation. So in this case, to create the standardized height, we took everyone's score and we subtracted 63.39 and then divided everyone's score by 14.33. And then that new set of z-scores will have an average of 0 and a standard deviation of 1. It's mathematical. That is the result of taking the z-score transformation, is the new average will be 0 and the new standard deviation will be 1. Not for the raw scores, but for the new set of z-scores. Because we're counting in standard deviations, the new standard deviation for those z-scores is 1. And because we've subtracted the average from everyone's score, the new average for those z-scores is in fact 0. If we added up all the scores, we would get 0 because we've subtracted the average from every score. And so that is how you then use PSPP to create z-scores, and also how we can reuse the descriptive command that we used in previous PSPP guides to look at the means and standard deviations of both raw scores as well as z-scores. See you next time. Thanks for watching this PSPP guide to creating and looking at z-scores in PSPP. I'm Dr. Jennifer Moses signing off.